Hello everyone, Cam Show, Majama. In a previous lecture that we studied about this discovery of proton, neutron and electron, that is fundamental particle of the atom. Today we are going to study about the atomic structure. The history said that number of scientists represented their atomic structure. They all are not accepted because the lack of stability. Out of this atomic structure, today we are going to study the two atomic structure. The first, Thomson atomic structure, and second, Rutherford atomic structure. Let's see Thomson atomic structure. J.J. Thomson in 1898 proposed that the atom have spherical shape. The radius of the atom is 10⁻⁻10 meter. According to him, the positive charge of the atom is uniformly distributed in a sphere, and the tiny particles, that is negatively charged electrons, are emitted in such a manner which neutralize the total charge of the atom. That means the Thomson atomic structure successfully explain the neutrality of the atom. The positive charge of the atom is uniformly distributed, and the negative charge particles, that is electron, are emitted in such a way which neutralize the whole atom. That means Thomson atomic structure successfully explain the neutrality of atom. The structure of atom according to Thomson is supposed to be like this. This one is a sphere, and negative charge electrons are emitted. This whole part is a positive particle. He also concluded that the mass of the atom is uniformly distributed in a sphere. J.J. Thomson atomic structure successfully explained the neutrality of the atom, even though this structure was not accepted. The reason behind this, when he tried to explain the atomic mass of the atom except hydrogen, he failed. Not even that, later on the experiment was conducted by the Rutherford. That observation is totally opposite than the structure of the atom which was represented by Thomson. Clear? So these are the limitations of the Thomson atomic structure. Okay, let's start with the next atomic structure, that is Rutherford atomic structure. Rutherford's atomic structure. Rutherford and his students performed the experiment of the scattering of alpha particles by the metal foil. They bombarded the alpha particles on the gold foil. The thickness of the gold foil is round about 100 mm. This gold foil is surrounded by the fluorescent screen. The radiation is emitted by the source of radiation. You can see in a figure. After bombarding, the observation made by them are: the first observation, the most of the alpha particles does not shows any deflection. They just passing through the gold foil. Second observation, the sum of the alpha particles shows little deflection. Hardly out of 20,000 rays, only one ray is deflected back at the angle of 180. If we accept the Thomson atomic structure, then according to Thomson, this is a solid structure because the mass of the atom is uniformly distributed. If this structure is correct, then alpha particle will supposed to be strike on this atom, then but obvious they have to deflected, or they have to bounce back. The rays should not pass through the atom. But the observation is quite opposite than the structure was represented by J.J. Thomson. Clear? Let's write down the theory. As we discussed, they bombarded the alpha particle on the thin foil of the gold. The radiation is emitted by radioactive source. The gold foil is surrounded by fluorescent screen like zinc sulfide. This one is the source of radiation. Here it is a gold foil which is surrounded by fluorescent screen. These are the alpha particles striking all the gold foils, and they develop the effect on the fluorescent screen. At microscopic level, if we observe, then these are the rays of alpha particle. Alpha rays. This one is a gold foil. These are the atoms of the gold. Beside this one is the fluorescent screen. Now just give attention. This rays is passing, but due to the extreme repulsion force, it shows deflection, slight deflection. This rays is just passed. Here also, these rays passing through gold foil. Here, this rays is strike on the nucleus, as we know that, right? It's bounced back. This ray, due to the repulsion, is deflected. Here, rays are passed. Here also it shows the deflection. You can see in this diagram, the most of the rays are passed through the gold foil. Very few rays shows the deflection, little deflection, and out of this only one ray is bounced back. Clear? So these are the observation made by the Rutherford and his student by performing the scattering of alpha particles by gold foil. Okay, what he conclude based on this observation, that we will see in a next board work. Please write down. Rutherford and his students, after performing the experiment, the observation made by them are: first, most of the alpha rays are passing through the gold foil. Some of them shows a little deflection. And third, hardly one ray out of 20,000 is bounced back at angle of 180. On the basis of this observation, he concludes the things that are: if the most of the alpha rays are passing through the gold foil, that means the most of this space of the atom is empty. Second, some of the alpha rays are deflected. That means this deflection is due to the extreme repulsion of the alpha particles. Alpha particles have a positive charge. That means in an atom there must be a positive charge particles, which shows the repulsion. Third, a few ray, that means out of 20,000 only one ray is bounced back. That means that particle, the size of that particle is very small compared to the whole atom. That tiny particles have positive charge. The mass of the whole atom is concentrated in it, because the mass of electron is negligible. Observation: first, most of the alpha rays are passed through the metal foil. Some of the alpha rays shows a little deflection. Third, a very few ray, that is the ratio is 1 out of 20,000 is bounce back at angle 180 degree. Conclusions: most of the alpha rays are passed through the metal foil. That means the most of the space in an atom is empty. As I show in this figure, some of the rays shows the deflection. This deflection is due to the extreme repulsion. That means this particle has positive charge. That means proton. The reason behind this, because the alpha rays is a positively charged. Third, the atom have an empty space. The protons are situated here. That means the mass of the atom is concentrated in this tiny particle, that is due to the proton, because the mass of electron is negligible. Hardly one ray out of 20,000 is reflected back. That means this size of this particle, it's called nucleus, is very small compared to the atom. These are the conclusions made by the Rutherford and his student. On the basis of this observation and conclusion, Rutherford represent the structure of atom. Rutherford nuclear model of atom. On the basis of observation and conclusion, he represented the structure of atom. The first point, space in atom is empty. The mass of the atom is concentrated in a nucleus. Nucleus have positive charge proton. Third point, the electrons are revolving around the nucleus in fixed circular path called orbit. Fourth, the size of nucleus is very small compared to an atom. The radius of atom is 10 raised to minus 10 meter and the radius of nucleus is 10 raised to minus 15 meter. Assume nucleus, the size of nucleus is like a cricket ball, then the first radius, that means the first electron that you found is 5 kilometers away from that. That much space is empty. Clear? I am showing the structure of atom. This one is a nucleus, is very small, and this one is electron. Let's discuss the drawback of Rutherford atomic structure. Rutherford compared his model with the universe. In a universe, the sun is steady and the other planets are revolving around the sun. Here, the nucleus is steady and electrons are revolving around the nucleus in a circular path called orbit. According to the Coulomb, when the two charged particles at distance r, the attraction force exerted between them, that is F equal to K Q1 Q2 upon R square. The attraction force exerted between two opposite charged particles Fc equal to K Q1 Q2 upon R square. I am showing in this diagram. Suppose this one is a Q1 particle have positive charge. This one is the Q2 particle have a negative charge. The attraction force exerted between them at distance r is Fc is equal to K Q1 Q2 upon R square, where Fc Coulombic force, Q1 and Q2 the charge of particles, R distance between them, K is a Boltzmann constant. The value is 1 upon 4 pi epsilon 0. Epsilon 0 is a permeability of the medium that you will study in physics. Rutherford compared his atomic structure with universe. In universe, as sun is steady and other planets are revolving around it in atom, nucleus is steady and electrons are revolving around the nucleus. Newton gave the force of attraction, that is Fg, that is gravitational force, into G, gravitational constant, m1, m2, that is a mass of planet 1 and planet 2, upon r square, distance between them, which shows similarity with the Coulombic force. So what happened? If we accept the model was given by Rutherford, then he failed to explain the Maxwell theory of electromagnetic radiation that we will see in a next lecture. According to Maxwell, any charged particle in a motion, they always lose this own charge. So what happened? Suppose the electron is rotated around the nucleus in this way, right? Then electron is continuously losing its charge. So the attraction force between the nucleus and electron is continuously increased. That means electron continuously change its path, and after some time this electron will mix with the nucleus, and if it is happen, then atom becomes unstable. That means Rutherford atomic structure does not explain the stability of an atom, and lack of stability, this model was not accepted. Rutherford model failed to explain the theory of electromagnetic radiation given by Maxwell. According to this theory, any charged particle in motion lose its own charge if it is happen, then the electrons revolving around the nucleus lose its charge and accelerated and continuously change its path. Approximate 10⁻⁻8 seconds, the electron is mixed with nucleus and atom becomes unstable. Lack of stability, the Rutherford atomic structure was not accepted. Once again, drawback of the Rutherford atomic structure: the attraction force exerted between the two opposite charged particles, that is Q1 and Q2, is given by Coulomb, that is F is equal to K Q1 Q2 upon R square, where the F is a Coulombic force, Q1 Q2 is a charge of particles, R is distance between them, K is a Boltzmann constant, the value is 1 upon 4 pi epsilon 0. Epsilon 0 is known as permeability of the medium. Assume that this one is a nucleus and this one is electron, then the attraction force exerted between them is this one. Rutherford compared his system with the universe. In a universe, the sun is steady and other planets are revolving around the sun. The same way, in his structure, the nucleus is steady and electrons revolving around the nucleus. The attraction force, the gravitational attraction force exerted between the planets and sun, that was given by Newton. Fg is equal to G m1 m2 upon r square, which shows the similarity with the Coulombic force. So we can apply the Coulombic force equation to the atomic structure given by Rutherford. If we applied, then Rutherford failed to explain the theory of electromagnetic radiation was given by Maxwell. According to this theory, any particle in a motion it loses on charge. That means suppose this one is the nucleus and electron is rotate around the nucleus in this way, then this electron is continuously losing its charge. Maxwell practically proved these things, so we have to accept. This electron is lose its charge, the attraction force from the nucleus is continuously increased, so electron changes path and becomes highly accelerated. After some times this electron is mixed with the nucleus, and if it is mixed with the nucleus, atom becomes unstable. So lack of stability, Rutherford model was not accepted. Clear? Okay, I am showing the path of electron if it loses charge. This one is a nucleus. The electron is supposed to be here. This electron losing its charge, right? So what happened? This electron continuously change its path like this, and after 10⁻⁸ seconds it will mix with the nucleus. So lack of stability, this model was not accepted. After that, Niels Bohr represent the structure of atom that we will see in a next lecture.
Rutherford experiment. In 1911, Lord Ernest Rutherford performed an experiment which leads to the discovery of nucleus. The setup used in the experiment is shown here. A radioactive source was placed in a lead block with a narrow opening. The radioactive source is rich in alpha particles. These alpha particles are allowed to pass through the narrow opening. A lead sheet with a slit is placed just after the lead box. These fast-moving alpha particles passes through the slit and hit a thin gold foil. The alpha particles were detected using a zinc-coated fluorescent screen. When the alpha particles strike the fluorescent screen, they produce scintillations. This experiment, Rutherford observed that 1. Most of the alpha particles pass through the gold foil undeflected. 2. Some alpha particles were deflected at small angles. 3. Some alpha particles were deflected at large angles. 4. Very few of them bounced back at an angle of 180 degrees.